Our last speaker for today is Martin Verzilli, who is CTO at one of sponsors, Manastech, and he has over 20 years of experience in the software industry. He has watched the birth of Crystal, and now, 13 years later, he's going to talk about the technical challenges that they faced to keep it alive. So let's welcome Martin.
Thank you. Well, when I heard that the theme of this conference was going to be the long term, I got really excited and I said, I really want to be there because I've been doing a bunch of things for a long time and I find a specific joy in the long term. There's a depth that you don't get any other way. There's no shortcuts. You need to let time pass. It's either that or I'm about to turn 40 and this is a midlife crisis. I'm not sure. Either way, valid reasons, I think. And I want to focus on an aspect of long-term things, which is change. I think it was kind of a sub-theme today. I heard in many talks, Denitsa's in particular, how to survive, to remain relevant, you need to be constantly adapting, and adapting requires intentional change. But there's an aspect of change in particular that I want to review with you, to go over with you, which is the interplay between change and identity. Sometimes we already said that change is necessary for long-term relevance, but certain changes sort of feel like you won't be the same after taking them, right? And then there's the question, the reason why my project exists, or any other aspect of life, for that matter, is it still there after this change? Is it still worth going on with this after this change? The complementary question to that is what you consider your identity, all of that big lump of stuff, your identity, or is it just a feature and maybe you can consider removing some of your requirements to your own identity to go on. And I will use a real life example of Crystal, something that happened to us a long time ago, and it's still relevant to some extent to the project. So I guess the first step is to talk a bit about Crystal. How many of you know Crystal, the programming language? Oh, wow. I wasn't expecting this. So I guess I can go a bit faster on this. Crystal is a programming language inspired by Ruby with a standard lib that is almost copied from the one in Ruby. But the main thing with Crystal is we wanted to capture the vibe of programming in Ruby in a compiled programming language. That means somehow we need to write a compiler that where you can throw anything at it and it sort of figures out the types for you, so that you get these duck typing sensations that you get from Ruby. If you see this example, you have an array there that gets a nil and a string. You just get one random element from it, and the compiler knows that it's either gonna be a string or a nil. You didn't have to tell anything to it. And also, there is a bit more power to it because you can ask if a certain variable is falsy, is not falsy, and then the compiler knows that now foo is a string, it's not nillable. So we call this nil tracing, and it's sort of trying to tackle the $1 million mistake of having null be a part of every type. But since it's a much younger language, we also wanted to have from the get-go a solid concurrency model in the language, and we took inspiration from Go for this. So you can use CSP coroutines to communicate between green threads and fibers. Just to be able to reuse code easily, existing libraries and the like. We make it really easy to bind to C libraries. Of course, you can't just do exponentiation natively in Crystal. You don't need to call into an external library for that. But this is just an example of how you will call into libm. So the origin story. We were at Manas, the company where I work, in 2011 in Argentina. We were mostly a Ruby shop, but we came from releasing and deploying a bunch of applications in C#, Java, Erlang, different languages. Of all of those, we were the happiest with Rails and with Ruby. It just felt good to write. It just felt good to model. It felt like a sort of Play-Doh for thinking. But some of those applications started to struggle when they became more successful, when they were put under more stress. So we, being a bunch of programming language nerds at the company, took the most intelligent decision possible, which is let's create a programming language to solve this. Not very smart. So we started with what would a compiled Ruby look like. And the first thing we thought is the $1 million mistake, right? Can we make a compiler that's intelligent enough to tell us when a value can be nil? So here you can see a Ruby script that is not very useful, that will take a nil value or a float, depending on a random call. I called it 3 times until the third time I got a runtime error. The same code compile and run with Crystal, it becomes a compile time error. So we were excited about this. We were playing with this idea, and it seemed like it would work. Then, since we were using LLVM and compiling to native code, it was really fast, and it had a really low memory footprint. And that was also very exciting. However, I need to say benchmarks are horrible. I'm doing something terrible here, showing a benchmark out of context. I'm just trying to illustrate a point of what we were seeing back then. In particular, there's a million caveats here. In particular, if you call in this line 43 instead of 42, Ruby will gracefully convert to begint, whereas Crystal will just crash because it's going to overflow and throw an exception. So this is not at all to dunk on Ruby, which is our load language here. And well, since we wanted global inference, we needed something else from the developer than what you would request from Ruby. We needed to ask the developers to specify the type of empty collections, so we could probably type check. So this was already a departure from Ruby. One that was since the very beginning of the language and no one really seemed to care much about. But I'm mentioning it now because it's going to be relevant later. So seriously, we didn't want to succeed with this. This was a toy for us. This was an experimentation benchmark playground. But then one of our colleagues decided to post about it in Hacker News. It got to the first place like for 3 weeks in a row, and suddenly we were getting contributors, people talking about it, posting benchmarks very out of context. It sort of blew up, and so we said, okay, maybe there's value in this. Maybe we should pursue it a bit more seriously. So the first idea we had, a very good idea, is to coin this motto, which is fast as C, slick as Ruby, which was like, okay, we want to be as expressive as Ruby, but we think we can aim at C-like performance. Again, probably a mistake in retrospective, defining yourself in reference to others. I don't know. And we decided to put him in written as early as 13 years ago. What were the goals of the language? Have the same syntax as Ruby, or at least as similar as possible. So we were already like sort of saying, hey, please, this is not Ruby. This looks a lot like Ruby, but never have to specify a type of a variable or method argument, which was already not true, because I showed you before that you needed an annotation. Be able to call C code easily, compile time evaluation and generation of code. This is to mimic metaprogramming from Ruby, things like method missing. We have a macro system, which is obviously not as powerful as Ruby's dynamic features. So that was 13 years ago. It's not very clear, right? Yeah, I mean, the original image is not much more clear anyway. Anyone has an idea of what this could be? What? It's a graph-based output of a chart. What it's doing is showing the dependencies between files in a big program in Crystal that the compiler needs to keep in memory all the time and update constantly just to be able to do everything that I showed before. Just to magically capture the types based on where things are called and with which arguments, without asking from the developer to add annotations. This needs to happen. And as you can imagine, it was insanely slow. It was a memory clog. It was really not auspicious, let's say. But when we started looking into this issue, the community, the incipient community we had, was super psyched, was super hyped up. Like they were porting Ruby libraries and saying, hey, I just, with a few little tweaks, I have 10x as performant code. This is great. And we were like, the moment these people start really betting on Crystal for bigger projects, they will have to wait minutes for their programs to compile. That's a no-go. So we decided to face the problem. And we realized that there was a tiny little thing that we could ask of developers so that the compiler's complexity would get manageable. We wanted to ask of developers to annotate IVARs. And not even because in cases like age here, age equals 0, we added some inference rules so that you could, like, it's obvious that it's an int. You don't need that notation for the variable up there. So okay, we said, yeah, this is a tiny change. Will it have any consequences? These are just some captures of messages we got as a reply to the proposal to change the language in this direction. Some people were really mad at this change, and it raised a lot of questions on the team, right? Questions of identity here. Like, we had to go back to the whiteboard and think, what is Crystal's reason to exist? Can it survive without this change? Can it survive after this change? And will Crystal be Crystal after this change? This is the main thing I wanted to share here. Like, I think if you change Crystal for your project, these questions will always arise if you live long enough, right? In our case, for us, it was really clear that it couldn't survive without this change, and that this change would help it survive. But we went back to our original goals from 13 years ago, and we reviewed them, and we saw that actually what we were stating here, that we wanted, that we will love Ruby's efficiency for writing code, that we love C's efficiency for running code, it would still hold with the proposal that we were making. So we decided to move forward because it was either this or ceasing to exist, basically. So just to stress it further, we added a note there that Ruby compatibility is not a goal. We never said so, but we were maybe responsible in how we communicated that at the beginning. Or not conscious enough, I guess. So we proceeded with the change. This meant a fork in the road, certainly, for the community. Many in the community felt let down by the project and left. You saw the messages before. This is funny, many were disappointed but stayed. Many years later, they are like, actually, it was a good decision. My code is clearer now. It makes sense. A lot of bugs just disappeared. Classes of bugs, right? And there was more buy-in in our communities, especially in people who came from other more static programming languages. For them, it was quite natural. And then you have this guy. I don't know where to put him. It's a bucket in itself. But anyway, we made a change. The community forked a bit, but mostly stayed. We decided to change the motto to a language for humans and computers, which still was aligned with the original goals, but was more self-referential, like what are my intentions, not so much how I compare with others. And that let us continue the project, and 4 years ago we reached 1.0. It's no longer a toy, it's production ready. There's many people using it in production. there's some businesses that depend on it to exist, which is for us a huge responsibility and also joy. This means also maturing for the project, of course. A 1.0 means you commit not to break stuff from the past and into the future, unless you go into a newer version, right, and into a major version. However, this is still a challenge for the project. And in what sense is it a challenge? As I said before, we have a fast enough compiler now. There's big Crystal code bases that have seconds of compilation times. For the amount of work that the compiler does for you, this is acceptable, I think. But at the same time, it's not fast enough. Why? Because if you want to have modern developer tools that react spontaneously, immediately to what you're doing, you need a compiler that is extremely fast, and that we don't have. We want to have a compiler like that. So we will need to continue researching what is possible. How do we make this faster? How do we make this more performant? Maybe even start dreaming of a 2.0 where we do break some things in service of this other goal that we have right now. However, something we don't know, which is it will never be this, right? We will never change the language so that just for having better tooling, we demand annotations everywhere. Why? Well, because it will break many of these, but also because there are other languages that already do that wonderfully in different directions, right? You have Go, you have Rust, you have TypeScript, whatever you want to pick. So that's where we kind of draw the line. Am I suggesting that once you write your goals, you are tied to them forever? No, I'm not suggesting that. I'm just saying that it's what says what is written there. Some changes will redefine you entirely, and either way you take is fine. But it's important for you to be aware of it, because you don't want to become someone else without realizing the implications of the decisions you are making. Yeah, that's it. Thank you.